Okay, so like I said, we are going to be doing the domain today. Now, first of all, this chart right here with all of the letters, these are the letters that classify your numbers. So, you got your integers, your real numbers, your imaginary, all that good stuff. We're really only going to be using the R, the real numbers, because that's what your graph is made up of. It's made up of the real numbers. And we're talking about the domain on a graph. You are only going to use this R for set builder. All right, so set builder notation is when we're going to see the R. And the way that you write it, you do 2 lines and then the R. And the reason why you write it that way is because you have to make it kind of bolded. So if anybody was looking at your work, they would know that you are talking about the set of real numbers, not R variable. Right. So that's kind of the difference. If it's bolded, it's talking about the set of numbers versus a regular old variable. So the set of numbers are. All right, over here in this box, it says asymptotes have parentheses or less than or greater than signs. Greater than or less than signs. And points are going to have brackets or the greater than or less than signs with the inequality bar underneath. So try to get out of the mindset of these are going to be coordinate points because we're talking about intervals today. All right, because domain and range, they're going to be in intervals. So even though it looks just like a coordinate point, it is not a coordinate point. It is an interval. All right, an interval. Yes?
So from now on, you must use brackets for coordinates?
No. This is like if you were to describe the domain and their points, you use brackets. But coordinate points still have parentheses. We're not talking about coordinate points today. All right, so domain, those are the x values. And you are going to find the domain by looking at your graph from left to right. From left to right. So you have to start on the left and then go to the right. So left to right for the domain. Okay, and we are going to learn how to do domain 3 different ways. Interval, inequality, and then set builder, which is what we talked about from the very beginning. So interval, inequality, and set builder are the 3 ways you need to know how to write domain. If I don't specify, if I just said find the domain, you can pick. I don't care which way it's in, but you do need to know all of them. All right, so we're going to start with interval first. We're going to start with interval first. Interval, you're going to be using the parentheses or the brackets. And you're going to say how far left your graph is going, comma, how far right your graph is going. All right, so that's going to be kind of the interval notation. Okay, my first graph here, what kind of function is that?
Linear. No, wait, no. Absolute value.
Absolute value, good. Absolute value. So for this absolute value function, I'm going to look and I want to say, okay, how far left am I going? Well, remember, arrows are going to go on forever. So how far left am I going?
All the way.
All the way. So forever in math is?
Infinite.
Infinite, yep. And since we are going left, left is going to be negative. So negative infinity. Which makes sense because we are using all of the negative x values. Right, because we're going forever to the left, so we're using all the forever negative x values. Well, how far right are we going? Infinity, and that's going to be positive infinity because right in math is positive, and we are using all the positive x values. Make sense? And you have parentheses around them because, oh, I forgot to tell you. Asymptotes and infinities. I forgot to put infinities up here. Infinities and asymptotes have parentheses. So asymptotes are going to get parentheses as well. The only thing that gets brackets are points. All right, let's do the next one. All right, first, what kind of function is this? Quadratic, very good. Now, it's a skinny quadratic, but eventually it's a U, right? So it is going to get wider and wider and wider. Does that make sense? Okay, so how far left is it going? All the way. So negative infinity, how far right is it going? All the way. So positive infinity. Four. Uvia, that's you, right? You four? How far left is this graph going? Yep, negative infinity, good. And 19. Tell me your name again.
Paloma.
Paloma, that's right. How far right is it going?
Infinity.
Very good, infinity. And 10. What kind of graph is it? Cubic, very good. All right. All right, this next one is stopping right here, and then it's going forever this way. So 20, what kind of graph is that? Radical. Is it even or odd? Yes. Even radical, so like a square root or a fourth root. And 11. Stephen, is that you? How far left am I going?
-4.
Very good. -4. And is that going to be a bracket or a parentheses? Is it a point? Yeah. Bracket. Bracket because it's at a point. So it's not an arrow. It's not an asymptote. It's not infinity. So it's going to be a bracket. So we're going all the way here to -4 and we're stopping. So point at -4 and then how far right am I going?
Infinity.
Infinity. Very good. And infinities get parentheses. So you can mix and match. That is okay. All right, so infinities get parentheses, points get brackets. So remember, this is not like a coordinate point. This is an interval. This is telling you what's happening to the left. This is telling you what's happening to the right. I'll give that a second. Yeah, I can answer it. Okay, so for this next graph, what is the parent or what's the function? Anybody can tell me.
Radical odd.
Hello.
Wait. Yeah, radical odd.
Okay. Nathaniel, you believe in? Okay, so yes, I heard radical. Is it odd or even?
Odd.
Odd, very good. And how far left am I going?
Infinity.
Very good. And how far right?
Infinity.
Very good. Make sure your left is negative infinity. Just be careful on that. All right, next one. All right, so this one is definitely the hardest. Definitely going to be the hardest. All right, so first of all, what kind of function?
Rational.
Rational. Very good. Rational. Now remember, your rational has an asymptote here and here. Okay, first of all, how many bananas do I have in my graph? 2. How many intervals am I going to have?
2.
Very good. So each banana is going to get its own interval. So for this one, always start with the left one first. No matter where it is or how big it is, you're starting on the left side. How far left is it going? Negative infinity. Very good. And then how far right is it going? 2, right? Yeah, a little less than 2. And so the way that we're going to put it with a parentheses, and that just says that 2 is not included, but we're getting really, really close to it. So parentheses are for asymptotes and infinities, and that just means that it's not included.
So we're not going to be that up there? There's going to be a parentheses right there?
Yeah, that'll be a parentheses.
Yeah, because like it ain't close, but it doesn't touch
Okay, and then we need a second interval. So we're going to look at this next banana. How far left is it going? 2 again, right? Because it's getting real close to that asymptote. And how far right?
all the way.
Infinity, all the way.
Yeah.
All right. So really close to the asymptote, and then forever to the right. You might see this being combined with like a U. That just means and. It just means that both of those intervals are a part of the same graph. Right, so don't get confused if you see the little U. It just means and. All right, let's do the next one. All right, so this one has an asymptote right there. So what kind of graph is that?
That's an exponential.
Exponential. Good. Exponential has the horizontal. So how far left is my graph going? Okay, negative infinity. How far right?
Infinity.
Infinity. Because is there an asymptote?
curve?
Yeah.
Curve was gonna keep going up.
Right, very good. So there is no asymptote here, so it will forever go to the right. It's just really steep. But like Steven said, it is curved still, so it is still going up. All right, this guy, got my graph here. My asymptote right here. So let's see, 24. How far left is it going? Yep, -2. And do I have a parentheses or a bracket? Is it an asymptote or a point? Good. Yep, parentheses because it's an asymptote. And 7, number 7. Do we have a number 7?
Yeah.
Francisco?
Yeah.
How far right am I going?
Positive infinity.
Very good. Positive infinity. All right. Any questions on interval notation? Are we good on interval? All right. Awesome. Let's do inequality next. We'll jump back up here to the top.
Francisco had a question.
Oh, what's up, Francisco?
That was the rest of
When what's her name? Paloma gets back. I cannot remember her name. What's up?
Was that pink one a log group?
Yes. Yes, sorry, the pink one is a log. All right, so for inequality notation, you're going to ask yourself the same questions. How far left am I going? How far right am I going? The difference is going to be your notation. So instead of having parentheses and brackets, we are going to have the greater than or less than sign right here, and then depending on whether it's a point or an asymptote will be whether or not you have the bar underneath. Okay? This stuff is always going to be the same. Less than x, less than. Alright, that is not going to change. So just ask yourself how far left, how far right. And in my examples here, we're going to be, we already found it. You use those numbers that you put right there. Okay, so let's do the first one. So I went negative infinity to the left because my graph is going negative infinity to the left. So I say negative infinity is less than, x is less than, and then we're going positive infinity to the right. Jordan, what's this one going to look like? How far left am I going? Infinite. So negative infinity, and then the less than, x, less than, that stays the same. And then how far right am I going? Infinite. So it's like that. Does that make sense? Okay. Let's see. Jakayla, help me with the yellow one. Help me with this one. What would be inequality? This, the third one. Negative what? Good, and then what? Good. What's going to go in between? Good. The less than, x, less than. Okay. 15. Mike. How far left do I go? Negative 4. Is this less than sign going to have a bracket underneath it?
Yeah, 'cause it's a point, right?
Very good. Yes, because that's a point. What about this less than sign? Is that going to have a bracket?
No, 'cause it's infinity.
Very good.
So on the signs, less than, greater than, are they always going to face to the right?
Mm-hmm.
They don't never change.
Yep. For inequality, they're always going to be just like that.
Except
So
they don't
like,
do that.
is it backwards? Is it wrong?
Yep.
Mm-hmm.
Mm-hmm.
No. If I would start.
Like if you were to flip this and put infinity here and negative 4 here,
Yeah.
but then flipped your inequality signs, then no, that would still be right. All right. Next one, negative infinity, less than x, less than infinity. That one, I think we got that down. Okay, for the rational function, once again, how many bananas do I have? 2. How many inequalities am I going to have? 2. Very good. So negative infinity, less than x, less than 2. Does that get a bar?
Yeah. No.
No, why?
Because 2 is not included.
Very good. 2 is not included. It's an asymptote. It is not a point. And the other one, 2 less than x, less than infinity. So this first inequality was from the first interval. The second inequality is from the second interval. What's up?
You know how that you know how that's basically like backwards.
Mm-hmm.
Will all
Rationals?
yeah, will all rationals be like that?
Mm-hmm. Yep, just be careful that your left has a negative infinity and your right has a positive infinity. But other than that, yeah. Okay, for the next one, it's going left forever and right forever. So negative infinity, less than x, less than infinity. And then for the log, how far left am I going? Negative 2. Does it have a bar underneath?
No.
No.
Yeah.
No, it's an asymptote. Yep. All right, and that's inequality notation. It's just got all this extra stuff in the middle. All right, you ready for the last one?
Yeah.
And then we'll be done.
Set
Set builder. Set builder is not hard. It just has symbols that you've never seen before.
You can't find that stuff on the calculator, right?
Mm-mm.
We can't use cell builder on the calculator.
It won't. The calculator won't help you for set builder.
Dang, okay.
Yeah, but that helps.
Not really.
Everything. So graphing got to do it too.
Well, I mean, you could graph it in the calculator. It'll give you a graph, but looking at the graph, you have to get the domain. All right, for set builder. Set builder is going to look like this. Those squiggles are like those squiggly brackets you do in, I don't know, English class. You know what I'm talking about?
Oh, yeah,
Yeah.
paragraph thing.
Yeah.
Here.
And then you have X and a bar. X and a bar. That's like saying X is going to be whatever I put in here. All right, so once again, it's just notation. All right, it's just notation. All right, so there's just going to be a lot of different kinds of notation we're using with set builder. All right, so go down here. Ugh. X in a bar. The one thing I do not want in set builder are infinity signs. So no infinity signs.
Oh, we use word.
All right, no infinity signs. We're going to use other symbols besides infinity.
Do you use signs right here too?
Do what?
You gonna put some little signs that we're gonna use? too?
Yeah.
Yeah, he just said something.
All right, so for set builder, I'm using all the left values. I'm using all the right values, right? I'm using all of the values. So the way that you are going to write that is you are going to say X. And then we're going to have this sign for, it's like in, like X is in, or X is using, or X is. It's a little, it's like a C with a line in it. So it's like a mixture between a C and an E. Okay?
Ain't no backwards.
Yeah, it's like a regular way E, but with a curve in it.
No, it's not. Wait.
Yeah.
Yeah. It's alright though. Alright, so this sign right here like means in, or X is using, or X is, alright? In. And then it's all of the real numbers. So that's why we're going to put the real number sign.
We just put XER.
Yep.
Alright.
So you're going to use this notation right here if you are using all of the X values. If you're going from negative infinity to infinity. What's up?
Okay, you know that E, right?
Uh-huh.
So like, what is an E in?
You can't put the E in the calculator.
Because like when I get, you know, those Dollar Tree calculators with cheap ones,
Mhm.
they got the big screen. And when I type something that's too big, it puts E.
Oh, that means, okay, that's a different E. There's a couple E's in math class. If it has like 1.3 E, like an E like this, and then 20 like that,
Yeah.
that's scientific notation. Times 10, and then that's the power.
I thought that was saying Aaron.
Yeah, that's scientific notation. All right, let's do the next one. Yeah. All right, so am I using all of the values in the quadratic? Yes, you are. So same thing. X in the bar. So X is using all the real numbers. The domain is using all the real numbers. So if I ask you what the domain is, this is saying it's all the real numbers. All right, so 12. Who's 12? 9, 10, 11. What is the domain of this guy in set builder? Same thing. So all the real numbers. X is all the real numbers. Not on everything. Is it going to be the same thing on the next one? No, because I'm not using all the real numbers on this one. All right, so on this one, remember, I don't want infinity signs. So look at the inequality. Ignore the infinity, and this is what you're going to put into set builder. So ignore the infinity. That's what you're going to put in set builder. You normally see it with the X first. So X is greater than or equal to -4. Make sure your alligator is eating the X, since it's eating the X right here when you flip stuff around. All right, so make sure your alligator's eating the right thing and you'll be fine. All right, almost done. Down here. Yes, what's up?
If you're looking for a squiggly line, they're kind of just like squiggly and aren't like that.
Yeah. Yeah, I won't be picky about that. Okay, so I think I heard Steven say same thing as the all real numbers, x bar. And then x is in all the real numbers. Which other one of these three will be all real numbers?
Award.
But
Exponential, yes, the exponential.
I'm not doing that.
No, we are. I'm going to come back to it. Alright, let's come back to this rational one. Alright, so you would think the rational one is going to be really complicated, but it's actually not. Remember, I don't want to mess with the infinities. So let's look at my graph again. I'm using all of these left values, right? I'm using all of these right values. Which is the one value I'm not using? 2. Why am I not using the 2?
Because that's what the asymptote is.
Very good. So, in set builder notation, we are going to say x cannot be 2. So x with the equal sign with the line through it says x cannot be 2. X is everything but 2. So we're going to use all the values but 2. And that's it.
But what about the other one? Because we got two asymptotes.
But we're doing domain, not range.
Yes.
Oh yeah, domain. I'm sure.
We'll do range tomorrow and I'll get the other one.
What's range?
Range is the Y value, man.
Okay, and then for the last one. Alright, so on this one, I'm only using the values from here over, right? So that means x, am I going to be greater than or less than?
X is greater than.
Greater than, do I have the equal to sign?
No. Yeah. No.
No, because it's an asymptote. And greater than what number?
-2.
Negative 2.
Negative 2.